So, okay, here we are again. We're having fun with lasers tonight, and and rocks I've gotten in the mail this week. Um, I'm getting this week. I'm getting last month's stuff that I spent my money on, um, and this is one of them. And this one's a nice one, man. Let's move these guys out of here. And we're gonna put that guy out there. Kind of roll it around. Check it out. Check the back out. These are cut in India, and they don't use the standard technique on machine cut diamonds. These are done by hand with this handheld device that allows them to set the angles and degrees and stuff, but they do it by hand, and um, it is totally cool to watch them do it. And the back on this is just as cool as the front, and the front's pretty cool, really truly cool. So how do you know it's a diamond, right? I mean, how do you know? All right, diamonds have all three isotopes of carbon in them. And that means that there's some carbon 14 in them. And carbon 14 will glow in all wavelengths. Alright, so here we go. We're going to shut the light off. And there's green. Not a trip, huh? So, now we got a red one. See if I can hit the target. And it's a blue diamond, so the red doesn't respond as well in the blue because the planes of cleavage are smaller. But it's acting, it's doing all right. And then there's blue. And it glows even in the ultraviolet. It's responding to the blue light real well. And you can kind of measure the size of the planes of cleavage and the associated unit cells of carbon, which is the smallest group of carbon atoms that create the crystal structure, by the way the light responds in the crystal, across the crystal. We cut them so that the planes of cleavage parallel the pavilion, this back part here. So the planes of cleavage are opening outwards, and when we look at the face of the diamond, the color is around the periphery and sparkles and stuff. And the center looks like there's nothing there. And that's not an optical illusion, it's not a reflection, you can see my finger through there, like there's nothing there. So that's what a diamond is. It's also 10 on the Mohs scale of hardness, which means if I bring a ruby over here, that I could scratch the ruby with my diamond. but I could not scratch the diamond with my ruby. And I'm probably not going to use this ruby. Okay, what I'm going to do with this ruby is light it up red. Look at that, huh? Woo, doodly doodly. Okay, now blue. Oh, whoa. That was the blue one. It glows red. It doesn't glow blue, it glows red. Okay, and this ruby has kind of a purplish tinge to it, so and it's actually kind of pink colored rather than dark red, um, kind of on the border between ruby and sapphire. And it doesn't matter what color the light is, it glows red. It's a ruby. And it's 9 on the Mohs scale of hardness, so I can scratch it with my diamond. And with my ruby, I can scratch just about anything else, any other mineral on the planet. Because 9 is like way, way, way harder than just about everything else. It's aluminum oxide, so corundum, and we use it as an abrasive and that sort of thing. Okay, so anyway, and then there's this. I don't know if I didn't leave the bag with me. Yeah, I did. Good. And then there's an emerald, and this is a nice emerald. And we got blue light, and it glows blue. Red light, and it doesn't glow much. It just kind of right around where the light is. The whole stone is not lighting up. And where'd my green one go? There it is. No, it's not. Aha. And now it glows all green everywhere. Not far out. But we're not getting those big light spikes coming off of there like I was getting off of the diamond, right? That's the diamond. And that stuff is actually the electrons coming off of the carbon-14. And you can see them. And they run into each other and they create what's called quantum foam, from which new particles form. And this stuff is not really as rare as you would think. Maybe these are. These are pretty nice. I'm kind of a collector, you know. And so, but the stuff that does this is not really that rare. You can find it in any river, creek, or dry wash on Earth. All of it, really, all of it. And you just kind of got to know what you're looking at. And if you don't check, if you say, oh, well, it's quartz. I know what quartz is. And quartz is, to most people, any clear crystal that they happen to find that they don't otherwise, recognize as something else. And most people don't recognize anything else. So, to say, oh, well, it's all quartz is not actually true. Um, in fact, I got about 10 tons of rock around here, maybe more, I don't know. And I actually can't find any quartz. I've been checking. What I find instead is carbon in its various forms, and it comes in both cubic crystals and hexagonal crystals. Cubic and hexagonal are basically the same thing, it just rotated in a different direction at 45 degrees from each other. So it's interesting to check, but if you say, oh, I already know what that is, you might not. You just might not until you check. And, since there's new stuff forming all the time, what you need to do is keep your mind open. Mind is like a parachute. It only works when it's open. Peace, y'all.